but hopefully by the end that will be obvious to you. We're going to talk about open source adoption, why is open source being adopted so quickly, and then finally talk about why Postgres is so innovative and is effectively the dominant relational system in the world today, and will continue to go so for many years to come. So forever is a long time. The universe is like 13 billion years old, so I don't think we're going to be around for 13 billion more years, but we have been around for 30 years, and we'll probably be around for another 30. This is a very exciting field. Postgres continues to get more and more popular. I attend about 30 events a year, and we probably have another 30 that I don't attend. So very active community that does a lot of activity. I'm not sure how many of you know the history of relational systems. But the relational system started in 1970 by E.F. Codd. System R, which eventually became Oracle, developed by IBM in 1974. Ingress, which I actually used as a professional in 1997. And Postgres started in 1986 at the University of California at Berkeley. So it was started by a professor and some graduate students effectively as an open source project. I started in 1996 when effectively the project had been stopped from the university, and we then picked it up as an internet team, and I have some of my team members here, and we've been doing that ever since. This is the computer I used in high school. It's funny, hardware doesn't last very long, right? Like, nobody uses it anymore. Postgres is 40 years old, and it's still being used. Kind of strange, isn't it? This is the most depressing slide of my slide deck. And the reason it's depressing is because it explains how commercial software is developed. And it explains why, there we go. And it explains why commercial software eventually dies. You're too young, but do you remember any software from like years ago that you used to use, that you used to love? Maybe we were in high school, and now it's not here anymore. It's gone. Why is that? Why does software just disappear like that? Primarily, it's because of this cycle. Normally, when a company starts a software project, they say, we're going to bring a new product to market. It's going to be exciting. People are going to love it. They hire a bunch of engineers, and they effectively work to innovate. And then in stage 2, they grow their market. So once they release their first version of the software, they effectively grow. They get bigger. They continue to get more customers. But at a certain point, they stop adding customers, right? I mean, you've kind of gotten as many customers as you're going to get. But what happens is that then you hit market saturation, and then step number 4 is profit maximization. What happens at that point, the company has as many customers as they're going to get, so they start to reduce development, they start to reduce support. The software kind of becomes old, it doesn't advance anymore. And then you enter maintenance mode where we're adding no new features to the software, okay? And there's no innovation, and then it becomes end of life. Now, I've been through this myself in my career. Many of you may not have been old, you're not old enough to do this. But I can tell you that's the way it works. I'm going to give you some examples. So, open source, how does that work? Starts with proprietary, basically creating some software, and then it has market growth, but it never really, it either continues or declines, but there's no profit. There's no maximization, there's no support to cut, there's no developers to cut, because we don't pay anybody anyway, so there's nothing to cut, okay? And also the source code is always available, so if somebody new comes along, and they want to create a new project, that's what we do. In fact, Postgres, when I started in 1996, was basically, it was in maintenance mode. It was a very small number of changes happening, okay? But myself and a number of people, Robert, when did you start? 98, there you go, 2 years after me, right? And you were as crazy as I was to do it, apparently so, right? And we effectively spent time taking the software, that had spent 10 years being developed in a university, and we just kept improving it a little bit at a time, and in fact we got more and more people, and eventually we got where we are today. Okay. I don't know I had time for this piece of this description. It's an amazing story, but it's a story of a computer game that started in 1984, okay? Finally released at the final version in 1998 and end of development in 99. Source code was leaked in 2000. Open source team takes it over. Company takes the open source and then makes a commercial product out of it again. And then they re-release the software that was originally in development in 99, and now this software is still under development years later. Kind of a strange story of a game, computer game that still is active. And in fact, this process, my son actually used to play this game, so I actually know quite a bit about the game, this kind of game. This is a flow chart of how commercial development works. And the problem here is that the company and the developers are on one side and the users are on the other. And it's an incredibly slow process for the meetings and the work and the testing and then the release to get to the users. And then when they have a problem, it has to go all the way back up. And this is why it takes weeks or months or years to fix bugs in proprietary software. In open source, the users and developers are the same people in a lot of cases. And every user can give us input on new features, and they can test, and they can do all sorts of cool stuff. So they can look at our features, they can give it feedback, they can review patches, they can test anytime, they can beta test, they can release the code, and then they can fix bugs at the same time with them. So this is why Postgres, which has no money, we aren't even a company. We don't own anything. We're like a club of people. We don't own anything. We can produce software better than Oracle and Microsoft and IBM. And Amazon too, okay? Because a lot of those companies started out looking at Postgres and thinking, that's good that these people are developing it, but we're gonna take the code, we're gonna make a better version of Postgres. And they tried for a while, but then they realized that no matter how hard they tried, this community of people was improving Postgres so quickly that the companies couldn't possibly compete with the speed of what we're doing. And I'm going to give credit to one company, Microsoft. They didn't even try that. They gave up initially. So we have 30 people from Microsoft, 40 from Amazon, AWS, about 40. We have a bunch of people from Hygo. Hygo has a team out in China doing amazing work. I was there earlier this year in Jinan. They had a conference in Jinan. We have a big conference coming in Hong Kong in November. We have a booth upstairs in room 409. I'll talk about that at the end. So a lot of activity going on. And what happens is that IBM has DB2, but they support Postgres. Microsoft has Microsoft SQL, but they support Postgres. Oracle probably hates us, but there's an Oracle Postgres in the Oracle Cloud, okay? Which I never thought I would see. Because it's very humbling to bring in somebody else's software and give it to your customers, right? It is. You think yours is the best. I never thought I'd see a Oracle Postgres, but it exists. I have a blog entry about it. You can see links to the code. It's pretty amazing, okay? So it's kind of weird. The other weird thing is, again, we have no money. We're just volunteers mostly, or we're sponsored by other companies, but we work as a team. And big companies will come to us and say, how can we help you? Now that is very strange to me, because normally in the corporate world, the little companies are always trying to do something with the big companies. Like, I want Microsoft to do this with me, and I want Amazon to ship me, and I want to, and we just kind of ignore those big companies as companies themselves. But they come to us like, oh, can we have a thing? Like Amazon did an AI workshop in Pittsburgh 3 weeks ago. Okay, they invited all the committers, all the sort of code internal people to come to Pittsburgh, spend 3 days and learn about how AI can help us, all right? That's great. AWS was happy to sponsor that. My company, EDB, sponsors a whole bunch of stuff like dinners and packaging and shipping special versions of Postgres. And then we have Microsoft, who does like a Postgres conference, and they have tons of people contributing. All these companies have tons of people contributing. So it's a weird process, very hard to explain. My father died a couple years ago. I don't think he really understood what I did. It didn't make sense to him. He knew I was, somehow he knew I was successful, right? But it wasn't, I don't think it actually like sunk in. Most people at church think I'm either a drug dealer or a spy. Because I go to these unusual countries. I usually just go to Russia a lot. I go to China, I go to Japan, I go to Brazil, and then I come home and I don't seem to have a job because I'm home. So again, it's a very unusual job to have, but it is very, very rewarding. When I started with Postgres, Robert and I, we were somewhere down here in terms of features and performance and reliability. But what was amazing is that even though we were below closed source software, we had an adoption curve that was higher. So we would, eventually we knew we'd catch up. I didn't realize how quickly. We're probably up here somewhere now. Nobody disputes that. I haven't heard anybody basically disputing it. And of course, all the people supporting us reinforces that. So I say that what I'm saying may sound ridiculous, and it may sound like I'm making this up, but I'm not. In the 90s, when I was a consultant, the big operating systems for enterprises were AIX, HPUX, and Solaris. That was it. Those were the big ones. I used HPUX. Oh, and I used VMS. Any VMS? Anybody? VAX VMS? No. Okay, too young. But VAX VMS was another one. But these were the, and it was hard to imagine that they would become obsolete. But HPUX and Solaris are both end of life. AIX is just kind of holding on as a reasonable choice. They've all pretty much switched to open source, mostly Linux, FreeBSD, and so forth. A lot of open source operating systems out there. Similarly, when I was a developer in the 90s, the dominant operating systems that I used were Informix and Ingress. Okay? They're end of life. They're not around anymore. Remember I talked about that life cycle where we go through the stages and we get to end of life, maintenance mode? Well, these have been through all those, these last three have been through those stages. Microsoft SQL, yeah, it's still around. Some people, a lot of people use it. It's not terrible. But again, if it was fantastic, Microsoft wouldn't be helping Postgres. They know there's something special about what Postgres offers. DB2, they've kind of given up. They're still around, but IBM's huge. But again, nobody's going brand new on DB2. Same thing with Oracle. Oracle's great, does a whole bunch of cool stuff, very complicated, has a lot of legacy stuff, a lot of features that were added for specific customers. So it's incredibly complicated to use, incredibly complicated to install, and frankly kind of fragile. Postgres is very clean, takes, what is it, Robert, 45 seconds to install, 20 seconds, okay? And the binary is out like 8 megs maybe. Like it's just tremendously efficient. So if you're installing in the cloud, you're installing it on a Raspberry Pi or a PlayStation or a phone, you can do that because it's so small, okay? So again, these have been through the life cycle for closed source. 3 of them are gone, 3 of them are kind of still around. But they're definitely in the decline. Very few people would deploy brand new on Oracle today. That's the way I kind of explain it. When I'm talking to customers, I'm like, let's suppose I'm a startup and I've decided that I'm going to standardize on Oracle. You'd be like, what? Like, why would you do that? Why would you start with Oracle? Because it's just very expensive, and it doesn't handle modern workloads the way Postgres does. I'm going to talk about that in a minute. So again, really, really exciting time to be involved with Postgres. We have a global team. So again, as I said before, we got people from China, Japan, Australia, all over Southeast Asia and Asia, India, Pakistan, all the way to Russia, Europe, US, Brazil, Mexico, all very active places. So anyone who has an email can get involved with our project. And again, we're improving in so many directions at the same time. Okay. So basically, Postgres doesn't die because it's a great idea, and that idea continues to be useful for enterprises. But let's talk about adoption. This survey was done about 10 years ago, so it's kind of old. But I love this slide. And again, most of you are probably students, so you don't have to kind of deal with this. But when I talk to enterprises and I say, why would you use open source? And they did a survey, and they said the number one reason people start using open source is cost. They want to save money, okay? That gets people excited. I want to save money, which is great. But what happens in this survey is they came back 2 years later and they said, okay, now that you save money, what is the real value of open source? And what they found was once they used open source, they realized that innovation and competitive features, lack of lock-in, and the quality of the software actually was a bigger value to the enterprise than the cost itself. So the cost itself gets people started, but once you're actually using it, you realize the cost is a minor issue. It's a minor value to you. And this is why we have 70 or 60 conferences a year, because there is just so much excitement about the software. And it allows you to do so much, and I'm going to talk in detail about that in the next section. Okay. I'm going to skip over that. So let's just talk about Postgres. I might have actually some time for some questions. Let's just talk about Postgres. So Postgres, again, built upon the relational systems that were designed in 1970 by E.F. Codd. These are kind of the relational foundations. 1986, we have a professor at Berkeley, University of California at Berkeley, who develops Postgres, and his general new idea is that he wants to make Postgres extendable. He feels that the relational systems in 1986 are too rigid. They do not allow you to create new capabilities inside the database, so therefore he wants to create an extendable system. So he basically creates this layout, which not only has the normal system tables, like here's my tables, here's my columns, here's my users, but I also have a table for data types, I have a table for indexing types, I have a table for aggregates and operators. All of a sudden, we do not have a static system anymore. We have a system that will continue to be improved. So for example, let's suppose I'm doing an application and I need a data type to represent a UPC symbol, that little barcode on products. Or I want to put book numbers in there. Well, book numbers typically are not part of a database. You don't have a data type for that. But we do ship an extension called ISN, which will add these data types for you to make it easier to write your application, right? What if suppose you're writing an application and you need a server-side language? Normally, relational systems have one server-side language. We have 12, 11, however many are up there. So, in fact, there's a whole bunch there's some of mine being listed here, okay? So, again, in terms of flexibility, people who are writing applications love this. If you're going to use specialized data types, you need specialized indexing. I know many of you know B-tree and hash, which are the traditional relational indexes. But we have Brin for full text for data warehouse, and we have Gin for JSON and full text search, and we have GIST for geometry types and so forth. So incredibly powerful indexing system that's built into Postgres. Why is this important? Because when I started, almost all the data you put into a database was relational. It was order entry, it was I want a product, I'm going to ship something. But what has happened in the past 15 years is that we now need to have data warehouse data in the database, we have web browser data in the database for JSON, we have mobile apps now we need to record data, we have Internet of Things, we have AI we need to store in the database, we have documents we want to store in the database, we have GPS and GIS data we want to store in the database, and even social media information we want to store in the database. So again, without an extendable system, you only have the part in red. With Postgres, and again, the second reason first reason Postgres is popular, open source. leveraging the smarts of people around the world. Second reason, extendability. It allows you to write modern applications using a database that is tailored to store your very complex data in modern applications. For example, full-text search. We support full-text search built into Postgres. This is a sample query from full-text search. We support NoSQL workloads in Postgres. This is an example of a JSON query. This is the key, this is the value, this is the key. So you're actually using this operator here and this operator here to do special access to JSON data, and using the specialized indexing we have and the specialized storage we have for these data types, it's very fast. It's not like we store everything as text and then try and fit it into a relational model. We have specialized data types for all of these examples. Range types. I'm not going to go into why this is important, but normally you have to have a start and stop time in a relational system. This allows you to put the start and stop time in the same column. There's an example of what it looks like. Geometric types. Here's an example. Give me the two closest points to that point there. This is very hard to do in relational systems. It's called nearest neighbor. I don't know how many academics we have here who do relational systems, but nearest neighbor searches efficiently are incredibly hard to do. We do it thanks to some developers in Russia. GIS, if you're storing geographic information system information, we have a GIS extension that does that. Here's an example of a GIS extension. If you're doing AI and storing vectors, we have PG Vector. You install the extension PG Vector, and it adds 3 new data types. Remember I showed you when we had the UPC symbol? Remember way back? Well, now we're adding a vector type, and then we're going to use the vector type when we define our table. All right? And we can actually, as you can see, store the vectors. This is all cut off, but this is a 1,536 dimension vector, which we are storing for these text fields right there. If your data does not fit in Postgres, then we have foreign data wrappers, so we can reach out to almost any data source, including Oracle and S3 and Hadoop, and pretty much any data source that's out there. We can go out, get the data, bring it back, and process it. Something like this. Okay. If you're doing data analysis, we have a very powerful system which has a lot of capabilities that you would use if you want to use Postgres as a data warehouse. You may still need a data warehouse, specialized software, if you have very demanding requirements, but most people find they can do most of their analysis straight in Postgres without having to go outside. Sharding is another feature I'd like to see in Postgres. Let's just talk about the community. The community is basically diversified, geographically, culturally, and is multi-company. So we have a lot of different people, a lot of different companies involved. It's not dominated by any one company, clearly. We are BSD licensed, which means that the software is free for any use. So if you want to use it in a proprietary product, you want to change it, you want to make a new version of Postgres, you're welcome to do that. And a lot of companies have done that in the past. We've been at this for 40, it says 35 plus, I guess 40 years now we've been at this. We have basically 25 years of annual releases. We have about 180 features every year. So we have Postgres 19, just coming out in September, October, and it has 180, I think that release is 204 additions to the database. Very few relational systems can put out a release every year with that many improvements. In fact, I don't think any of them can. We have quarterly minor releases, and we are the most loved database, which is kind of cool. Okay? If you think I'm making this up, and I've just made all this up, if you go to this website that I've created, it allows you to see pretty much everything that's going on in Postgres at that individual moment. This is an IRC channel where you can see activity about Postgres. Here is the next Postgres event. Turns out it's in Hyderabad, India. I think it's at the end of August, Robert, I think. It's coming soon, yeah. This is the most recent mention of Postgres in the media. This is the most recent news article we've sent out. This is the most recent blog entry here, the releases we're working on. Here's Postgres 19 Beta 2. So this is what we're working on right now, okay? And we've actually started development on Postgres 20. So we're doing we're fixing 19 and we're really working on 20 kind of at the same time. And we're actually in a commit fest, if that means anything to you. Here's our most recent announcement. This is a conference we're having in New York City. So they just announced their schedule. The most recent email and the most recent general email kind of asking, and if you click on any of these, it'll take you to the email or take you to the blog or whatever. So again, I'm not making this up. It sounds crazy, but this is actually the world we live in. So thank you very much. I appreciate your time. I have the time for like 2 questions, which is good. And who has the first question? And somebody can translate, hopefully. I understand. Yes, sir.
They will graph supporting, right, for the next release. Tell us a little more about that.
So what's in the next release? Yeah. So remember I told you back here, where was it? Yeah. So we don't have like one thing we work on because we aren't coordinated. We don't have like a meeting and say, hey, let's work on this thing. So what we have is something where we're adding things all over the place. Robert, you actually were working on that kind of thing for 19. You want to talk about that?
Yeah.
Sure.
So I think, as he's saying, like different companies have different workloads, so they have different needs they put in. But 2 sort of big things that I worked on or was paying attention to, one is a feature called Repack, which there are extensions that kind of do versions of this, so we're bringing that into the core system. And then sort of overhauling the auto vacuum algorithms that run internally to do like garbage collection and cleanup inside the database. So that's 2 things that I was sort of more paying attention, but obviously there were 200 other ones that were in there, so yeah, there's a lot of other ones. Yeah.
Unfortunately, we are out of time. Thank you very much. I am giving 2 talks tomorrow, one on AI and one more specifically about Postgres. So take a look at those on the schedule. Thank you.